I will share it with you all. So flow of charge per unit time is called electric current. Remember, we can't write flow of electrons per unit time because we believe that it's a flow of charge. We do not consider it as flow of electrons, okay? So flow of charge per unit time is called electric current. So mathematically, I can say that current is equal to charge over time, total amount of charge which is flowing through a wire and the time taken by the charge to flow in the wire from one end to the other end. Okay, obviously charge will flow through a wire or in a conductor. So this would be a word equation for it, but in symbols I can write I equals to Q over T, which is very famous equation in physics and even you have studied in IGCSE as well. So where I is symbol of current and Q is charge and T is time. That's good. SI unit of current quickly we can write because we have studied in IGCSE as well. SI unit of current is ampere. So current is measured in ampere. And we can even define 1 ampere as 1 coulomb per second, when 1 coulomb over 1 second. So this can be a separate definition of 1 ampere. So it means we can define ampere as, for example, if I want to define 1 ampere, so I can say that 1 ampere is, I'm sorry, current is 1 ampere if 1 coulomb charge is flowing in 1 second. Then we can say current is 1 ampere. Okay, so even you can write like this. For example, if they are asking you define 1 ampere, so you can write 1 coulomb over 1 second. If you want to write in word equation, so you can write in this way. There's no harm in that. Even it will be acceptable. Okay, so the situation is just like this. For example, if there is a wire here, suppose this is a wire, it's a cross section wire, maybe. I'm sorry for my drawings, but
सर ये आप पेन के थ्रू बनाने के या फिर माउस?
पेन के थ्रू।
ठीक।
क्यों, मेरी ड्राइंग अच्छी है बुरी है?
नहीं, आपकी हैंड राइटिंग वो अच्छी लग रही थी। मैंने कहा माउस से कैसे लिख रहे हैं आप?
पेन से लिख रहा हूँ। इनफैक्ट टच पैड है, टच पैड पे स्टाइलस है, ऐसे लिख रहा हूँ।
जी।
So for example, if we are saying the charge which is flowing through this wire is 50 coulomb, and the time it takes is maybe, for example, it's 1 minute. So calculate current. Maybe the direction of current is from left to right, from A to B, for example. So obviously I can calculate current like this. I would be equals to Q over T formula. Q would be 50 and divided by, remember, you need to use time in seconds. So in 1 minute, there are 60 seconds. So 50 over 60 means 5 by 6. So what will be the answer? Someone please calculate it.
Sir, I'm calculating.
Yes, please give me answer.
5 by 6 is 0.83.
0.83 amperes. Okay, so this will be the amount of current. Okay, now generally, There are two ways in which we treat with the current, or we deal with the current, you can say. Someone please mute your mic. I'm sorry because there was some noise. Anyways, so we treat current in two ways. One is called conventional current, and the other one is called electronic current. Now, it's very important to know the meanings of these two currents. Very important, very, very important concept. Electronic current. And I must say that these two are two names of same thing. Meaning there is one thing which is current. So these are not two different currents. We can say these can be two names of one thing. Okay, what is the difference? So actually, in reality, basically, we all know that charge exists in the form of electrons. If you remember in our last chapter, I told you that charge can be either only integral multiple of electrons. Okay, so if we are saying here that flow of charge per unit time, so it means there can be number of electrons which are flowing per unit time. Okay, so in reality, current is only due to flow of electrons. Okay, so it means the current in which we consider the movement of electrons, and electrons always move from negative to positive. Negative referred as lower potential point, and positive is always referred as higher potential point. Okay, so we already have this idea that actually negative is considered to be a lower potential point and positive is considered to be higher potential point. And so electrons always move from negative to positive. So it means we can say that electrons always move from lower potential to high potential point. So it means I can define electronic current as, we can say that current due to movement of electrons from lower potential to higher potential. Okay, from lower potential to higher potential. And remember, lower potential means negative and higher potential means positive. So lower potential means negative and higher potential means positive. So you need from negative to positive. But on the other hand, we can say that conventional current is current which is opposite to movement of electrons. If I'm saying opposite to movement of electrons, so definitely it will be from higher potential to lower potential, meaning from positive to negative. Higher potential, which is positive, to lower potential, which is negative. And in our circuits, I mean in our syllabus, in most of our DC circuits, we always consider conventional current direction from positive to negative. You maybe have heard from some teachers that yes, it's basically conventional way to take current from positive to negative, because in the beginning it was taken from positive to negative, so it's a tradition. So that's why we have to consider current in the same way, always from positive to negative. But in reality, it is from negative to positive due to the movement of electrons. But it's not like that. See, I have in the beginning I told you that these are two names of same thing. Okay, now tell me one thing. I mean, let's discuss a situation. Suppose if there is a wire here, okay. So if I divide this wire into different cells, maybe these are the some places, okay, and electrons are in it. So definitely electrons, if on getting a push, electron would be moving. Maybe this would be negative terminal and negative side of the wire, and this would be connected to the positive side of the wire. So electrons would be moving from negative to positive according to our definition. So it means, for example, there was an electron here, then it moved one step forward. It obviously it will move here, so it will come at this point. Okay. So all of you know it very well that when electron leaves its place, so what it leave behind? Anyone please want to comment on it? What it will leave behind when electron leaves its
Would
place?
leave empty space.
Empty space, that empty space is
Vacancy.
that can be called as
Vacancy?
a positive charge, vacancy.
Yeah, sorry.
It would be a vacancy, okay? So it means when electron will leave its place, a vacancy will be created. So this vacancy will be filled by one more electron from the backside, definitely. So it means there will be one more electron which will eventually come here and fill this vacancy. Okay. So in this way, as the electrons would be moving forward, so vacancies will be created backward. Can I say like this? I think I should draw it in the other direction. I'm sorry because due to some screen diagram, it happens, but I can redraw it. For example, if I consider this as negative and this as positive, and we were talking about these electrons, maybe this was an electron here, this was an electron here, so all the electrons are in at their places. So let's talk about, let's start from this electron. So when this electron will move forward, so a vacancy will be created. So definitely this electron will come forward to fill this vacancy. So then vacancy will be created here. Then this electron will come forward to fill this vacancy. So vacancy will be created here. This electron will come forward to fill this vacancy. So vacancy will be created here. So in this way, this process will be continued. And you will see that as the electrons are moving to the right, these vacancies are moving to the left. And you see this. It's very clear. Okay. So it means it's the same thing if even if you consider the movement of electron from negative to positive, or if you consider the movement of vacancies from positive to negative. Can you see this? So it's the same thing. Actually, it's only one thing that actually it's a flow of current, flow of charge. So it all depends on you that either you consider the flow of the positive charges. I should not say flow of the positive charges. I should say that creation of the vacancies, creations of the positive charges, by the way, because in reality, positive charges do not move, only electrons move. And due to the displacement of electrons or due to the movement of electrons, some vacancies are created. And those vacancies are always filled by other electrons. So definitely, whenever electron will move, so it will leave behind a vacancy. So if we consider the movement of these vacancies, which are positive charges, you can see in the opposite direction to the movement of electrons from higher potential to lower potential. So this will be conventional current. So I can call it conventional current. This would be conventional current. But if we consider the movement of electrons in reality, by the way, so this will be electronic current, as it is very clear from its name, the current due to the movement of electrons from lower potential to higher potential. But here, technically, I have not used the words here in which I just mentioned this thing that the movement of the positive charges. No, I even technically I wrote here the current which is opposite to the movement of electrons. I didn't mention that it's the current which is due to the movement of positive charges. No, I mentioned that current which is opposite to the movement of electrons from higher potential to lower potential is called conventional current. Okay, so it means that it's the same thing. By the way, there is no difference between them. So is it clear, students? If there is any confusion, so please ask me. If there is any confusion,
No, sir.
that's good. That's great. That's good. So anyways, then the next thing is, uh, first part, I mean, there will be difference in my order of topics. I will deal with the current first. Okay, after covering all the relevant things to the current topic, then we will do the resistance and potential difference, all the rest of the concepts, remaining concepts. Okay, so if we talk about current, so far we have done only formula. Now, how we can measure current, measuring current in the circuits, and maybe after 40 minutes it will be automatically, this meeting will be ended up. So I will restart again. Okay, so all of you please rejoin after 40 minutes. So measuring current. Current is measured by an instrument which is called an ammeter. All of us are familiar with it. Let me make it more short. So instrument which we use to measure current is an ammeter. So we use an ammeter, and the symbol for an ammeter is, it can be a circle in which A is written like this. Now there are two important points which you should know about the ammeter. Ammeter is always connected in series. Remember this thing. Ammeter is always connected in series to the component through which current is to be measured. Okay. What is the meaning of component? Component can be any lamp, it can be a resistance, it can be a thermistor, whatever is in the circuit which is connected. So if you want to find out the current through that component, which is flowing through that component, so you should connect an ammeter in the series. For example, suppose if there is a lamp, I'm sorry. For example, suppose if there is a lamp here, the symbol for lamp is just like this with a cross in it, a circle with a cross in it. Okay, so if you want to measure the current in this lamp, so either you can connect a meter here or you can connect a meter here. Both emitters will give you same reading because current remains same in series. We know that, okay? So it means to measure current in this lamp, we need to connect emitter in series with the lamp. These can be two possible positions of the emitter. Then the next important thing about emitter is emitter has very low resistance. Emitter has very low resistance. This is very important point. Why emitter should have very low resistance?
So it's the maximum current can pass through.
So that maximum current would flow through it. For maximum current,
So least current loss.
exactly. So that maximum current would pass through it. And there would be no energy dissipation, energy loss, energy consumption. You can also use word consumption. by emitter. Okay, so it makes sense, by the way. If suppose if emitter would have high resistance or considerable resistance, so definitely there can be energy losses here. But we need to allow current, maximum current through the lamp so that the lamp could lit with the more, I mean, maximum intensity or can get the maximum energy to be on. Okay, so this is one of the major concern about the emitter. Remember this thing, emitter is always connected in series. Okay, that's good. Then the next thing is current in different combinations, maybe current in series, current in parallel, current in series. All of us are familiar with it. I'm just quoting it. Current in parallel combination. So current remains same in series. And current is divided in parallel. So basically, in both of these possible distributions of currents is based on one law, remember. And we will do it in more detail when we will do Kirchhoff's laws. But right now, I can just give you an idea. The total charge is conserved due to conservation of charge, due to principle of conservation of charge. What is the meaning of principle of conservation of charge? Any no
Total charge is the same.
total charge always remains same. So it makes
Yes.
sense, by the way. Yani, no charge can be destroyed, no charge can be created. Whatever charge is given to the circuit, so it has to come out. I mean, it has to be conserved all the time. For example, if we talk about series combination, for example, this, I'm sorry for lines. For example, if this is a wire through which current is flowing and there is a component here, maybe it's a resistor, one resistor, and maybe there is one diode. So here we can say that current remains same in series because whatever current, it is basically distribution of the charges Q by T. So it means Q charge is flowing, by the way. So Q charge is flowing through it. So whatever charge we have transmitted here into the wire, so it will be on the other side. So it should be constant throughout. That's why it should be constant. And can you please excuse me for a minute? I need to attend a call, very important call. I'm sorry. Okay,
Okay.
just I'm muting my mic for a minute. So okay, students, where were we? I hope all of you can see. So only 9 minutes are left, and then we will resume meeting again. I will restart again. Okay, so the code will be same, even the passcode will be same. Okay, so it means that whatever the current through this resistor and this diode, it will be same because the same charge will be flowing through it in the same time. But on the other hand, if we talk about this combination, for example, this is resistance and then here it is a diode which are connected in parallel combination. So whatever current is going into this circuit, maybe it's 3 amperes. So for example, diode has low resistance as compared to this resistance. So for example, 1 ampere is flowing here, so 2 ampere would be here. So but here after reaching this point, it will be again 3 amperes. So whatever charge which uh, we allowed to enter into the circuit, that should be same. So charge should remain same. Okay, got it? So remember this fact, and we will inshallah do it in more detail when we will be doing Kirchhoff's laws. Okay, so this was one of the concern for the current. Okay, then further there can be there is very important equation which is called an equation for current. This can be a new topic for you because you have not studied it in your IGCSE. This is called an equation for current. So please concentrate, all of you. This is also called drift speed equation. So actually, by the help of this equation, we will be able to find out the current which is flowing through the wire, inside the wire. Okay, and we will also discuss the factors on which that current depends, and we will also introduce a concept of drift speed. What is the meaning of drift speed of electrons? So let me explain, and let me draw some diagrams to explain you all. So the first thing is the concept of drift speed. Then further, I will be able to use, just a minute. I'm sorry, let me Actually, I wanted you to draw this diagram, but now it will be more clear. You can see. So can you see the screen now? Can you
Yes,
please
sir.
the same window which I was showing you?
Yeah.
Okay. Okay, so this is the situation. So actually, it's a cross-section view of the wire. Okay, and you can see the flow of current is from this end to this end. So it means current is flowing, and we believe that this would be the positive terminal. Definitely, I can say that this can be the positive side and this can be the negative side. Why? Because current is flowing from positive to negative, and the movement of electrons are from negative to positive because electrons are having negative charges. So this is an electron, by the way. They have even mentioned it. Okay, so electrons will be drifted towards the positive end. And one more thing which I should mention here, if we believe that it's a negative side of the wire, so I can say that it's a negative plate. Maybe I can consider it as a negative plate. So 1, 2, 3, 4, 5 negative charges. So I can draw 5 positive charges on the other end just to show it that these two are having same charge. Okay, so the situation is just like this, that for example, if there's a negative plate here and there's a positive plate here, it's a positive plate, it's a negative plate. So can I say that there will be electric field between these two plates, and the direction of electric field will be from positive to negative, and this electric field will be a uniform field, and the electrons which are drifting towards the positive plate, for example, these are the electrons with drift speed. So these are in the opposite direction of the electric field. So this is basically electric field between the ends of the wire. Okay. So there is a uniform electric field between the ends of the wire, and electrons are drifted towards the positive end in the opposite direction of the electric field. And this speed will be constant speed. So this is the basic concept of drift speed. Now let me write down the definition of drift speed. For example, if I write drift speed definition, this is maximum uniform speed remember, it's an average speed of electron by which electrons are drifted towards the positive end or attracted towards the positive end, you can say. Of the wire opposite to direction of electric field.